All right, let's talk about artificial intelligence. To really get what's happening today, you have to understand that there have always been two competing ideas, two minds, if you will, battling for the future of AI right from the very beginning. So we're going to skip the usual buzzwords and dive right into this fundamental conflict.
You know, it all really started with this one simple question, but it's a huge one. Back in the 1950s, pioneers like Alan Turing asked, "Can machines think?" That single question, that's the seed for everything. It's the driving force behind decades of research, arguments, and amazing breakthroughs. And honestly, it's the mystery we're still trying to solve today.
So what even is AI when we boil it down? Well, at its core, it's about making computers that can do things we typically associate with the human mind. You know, learning stuff, reasoning through problems, finding solutions. And look, this isn't some far-off sci-fi concept. You are using it constantly, every single day. When you punch something into Google search, or Netflix suggests a movie you actually want to watch, or you just ask Siri about the weather, yep, that's AI working behind the scenes. It's already here.
And it's not just in our pockets or our living rooms. AI is a massive deal in the business world. Just look at these adoption rates. Things like robotic process automation and computer vision are being snapped up by all kinds of industries, from the factory floor to the hospital. This isn't a someday trend. It's happening right now, and it is totally changing how work gets done.
So here's the game plan for our deep dive. We've just touched on the basics of what AI is. Now we're going to meet the two big competing ideas of AI. First up, we'll get to know symbolic AI, who we'll call the logician. Then we'll meet its rival, deep learning, or the learner. And finally, we'll see how this whole rivalry led to the AI explosion we're living through right now.
Seriously, you can pretty much see the entire history of AI as this one big debate. It's like a tale of two philosophies, each one trying to build an intelligent mind in a completely different way. And as we'll see, each one has its own incredible strengths and some really critical weaknesses. To make this easier, let's just imagine them as two different characters, okay? On one side, you've got the logician. This is symbolic AI. It thinks by following a super strict set of rules that we humans program into it. Then, on the other side, you've got the learner. This is deep learning. It doesn't follow a rulebook at all. Instead, it learns by finding patterns in tons and tons of data, kind of like how we do. This is the central conflict we're going to unpack. So let's meet our first character, the logician. This is what you might call good old-fashioned AI, or GoFi. This was the first real crack at it, where the early pioneers thought, hey, we can build a thinking machine by just writing down all the rules of the world and feeding them into a computer.
And the idea, you have to admit, makes a lot of sense. You just represent ideas as symbols, like the word cat stands for the furry animal. And then you write a bunch of logical rules, like if it has whiskers and pointy ears, then it might be a cat. The whole goal was to copy that step-by-step logical thinking that we do when we're consciously trying to solve a puzzle.
And you gotta understand, the folks behind this, they were not thinking small. This quote from Newell and Simon really captures that huge ambition. They basically said, look, if we can just build the right system of symbols and rules, that's it. We will have created a generally intelligent machine, period. They thought they had cracked the code.
And you know what? For a while, it seemed like they were right. Symbolic AI was an absolute genius at structured, logical problems. Things that we humans often find pretty difficult, like complicated math or IQ tests. But it completely fell apart when it came to the things we find easy. Things like recognizing a friend in a photo, getting a joke, or just having basic everyday common sense.
This led to this really bizarre, fascinating discovery called Moravec's paradox. It turned out that teaching a computer to be a master chess player or an expert accountant, that was the easy part. But teaching a computer to have the skills of a one-year-old baby, just to see the world and not bump into things, that was almost impossibly hard. The logician's rulebook just couldn't capture all that messy, unconscious, gut instinct stuff that makes up so much of our own intelligence.
So, with the logician hitting a wall, a totally different idea started to gain ground. It was time for our second character to take the stage, the learner. The idea here was, instead of programming rules from the top down, what if we could build a system that learns from the bottom up, just by experiencing the world?
And where did they look for inspiration? Well, they looked at the most powerful learning machine we know of, the human brain. The whole concept was to build an artificial neural network that could learn to see patterns in data in the same way the neurons in our own brain learn from everything we see and hear. So how does this actually work? Well, imagine a network made up of layers of tiny, simple processing nodes, kind of like neurons. You have an input layer that takes in raw data, say the pixels of a photo. Then you have hidden layers in the middle that do the heavy lifting, the processing. And finally, an output layer gives you the answer, like cat or not a cat. The real magic is that the network learns by tweaking the strength of the connections between all those little neurons over and over again.
Now, the training process might sound really complicated, but it basically comes down to 4 steps, repeated millions of times. First, data flows forward through the network and it makes a guess. Second, it checks its guess against the right answer and calculates how wrong it was. Third, it sends that error message backward through the whole network. And fourth, it uses that error to slightly adjust all the connections to make a better guess the next time. It's just a cycle of guess, check, and correct.
And this was the game changer. This ability to learn from experience unlocked all those things that the logician just couldn't handle. All of a sudden, tasks that depend on intuition and recognizing subtle patterns, like understanding speech, translating languages, seeing what's in a picture, were actually possible for a computer to do. This changed absolutely everything.
So, we've met the logician and we've met the learner. And that brings us to today. The AI revolution that we are all living through right now, it's a direct result of the learner's big win. But the story isn't quite over. Let's see how these two minds really stack up against each other and what might be coming next.
This table really lays out the differences, doesn't it? Symbolic AI, the logician. It thinks with pure logic and rules. Deep learning, the learner, thinks with patterns and examples. Symbolic AI is terrible at learning. That is literally deep learning's greatest strength. But here's the big trade-off. Symbolic AI is a white box. You can look inside and see exactly why it made a decision. Deep learning is often a black box. It can give you an amazing answer, but it can be really hard to know how it got there.
So almost every major AI breakthrough you've heard about lately, from ChatGPT to those incredible AI art generators, is powered by deep learning. And most of them are built on one specific super powerful design called the transformer architecture. That's the engine behind the tools that are blowing everyone's minds.
So what's the secret sauce in these transformers? Well, it comes down to a few clever tricks. The biggest one is something called an attention mechanism, which is a fancy way of saying the model can figure out which words in a sentence are the most important ones to pay attention to, just like we do when we read. That, plus a few other innovations to keep things running smoothly, lets them learn incredibly complex patterns, especially in language. That's where they get their power.
So, does all this mean the logician is dead? A relic of the past? Well, not necessarily. In fact, one of the most exciting new frontiers in AI research is this idea of a hybrid approach. Sometimes it's called neurosymbolic AI. The goal is to combine the structured, logical reasoning of the logician with the powerful, intuitive pattern matching of the learner. The thinking is, maybe real intelligence needs both.
And that leaves us with the ultimate question, really. What's the final path forward for AI? Is it going to be through perfecting pure cold logic? Is it going to be by scaling up these massive brain-inspired learning systems? Or will true artificial intelligence only be born when we finally figure out how to get these two very different minds to think together as one? The answer? Well, it's still out there waiting to be discovered.